Hello and good afternoon, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Network Plus course, and this afternoon's video tutorial is going to be our solution set for Worksheet 12 due tomorrow evening. And we're taking a look at IPv4 subnetting. We're going to be doing some Class B subnetting, or subnetting of Class B addresses, and some subnetting of Class C addresses. Now, we're given the IP address, but we're going to start our subnetting from .0. So in the fourth octet, we're going to start with a .0. So let's dive in here. And this is sort of a continuation to Worksheet 11, where we did some Class B subnetting. So here is the IP address that we have, right? It is 197.47.201.57, but that's the IP. So what class address is this? Well, it's Class C. We know that because the Class C address starts with, 011 as its value. So, or I'm sorry, I got that backwards. We're doing that with when we did the Class B, we were at 128 to 191, and that was 10 were the digits that started out for the Class B. For Class C, it's going to be 192. Whoops. To 223, and those start out 110. So we've got the 128 and the 64 gives us our 192, and then if we were to fill in the remaining values, 1, 2, 3, 4, we would have 16 plus 192, and that would give us, what is that going to be? 208? Yeah, 208 plus 8 is going to be 216 plus 4 is going to be 220 plus 2, 222 plus 1, 223. So the first three bits, high order bits in the first octet for a Class C address are going to be 110. For a Class B, it's just 10. And then we've got the other bits that can have values 1, 2, 3, 4, 1, 2, 3, 4. There we go. And this was our Class B, which we're going to be looking at shortly. So it's a Class C address. The default mask in binary, it's a /24, so 4 dot excuse me 4 1 2 3 4 dot 1 2 3 4 5 6 7 8. In decimal, it would be 255.255.255.0. So we need 13 subnets, and we'll come back to that in a second. We're going to leave this field blank. So the new subnet mask in binary, so how do we get from we need 13 subnets to what's the new subnet mask going to be? Well, if we need 13 subnets, we know that 2 to the 1 is equal to 2, 2 to the 2 is equal to 4, 2 to the 3 is equal to 8, and 2 to the 4 is 16. So just like Worksheet 11, we're going to overshoot the odd number, 13, because we're working with powers of 2 for the subnet. So we're going to borrow, and you can see here clearly 2 to the 4. So we're going to say 1, 2, 3, 4. So there are our 4 network bits that we're going to borrow, and then we have our remaining 4 host bits. So the new binary mask, or the new subnet mask in binary, if we were to borrow the bits, would be 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4. And then let's put our host bits in there. 1, 2, 3, 4. And so we would have a new subnet mask. It would be a /28. Because 28 bits are being used for the network portion of the address. Our new subnet mask in decimal is 255.255.255.128 plus 64 is 192 plus 32 is 224 plus 16 is 240. So highlight the rightmost 1 bit in the binary mask, and this is going to give us our block size. So we'll stick with green, and we know that the value of that bit position is 16. So the block size is going to be 16. So number of possible subnets, well, 2 to the 4 equals 16. So it just so happens that our block size matches the number of subnets. And again, that is, in this case, it'll be different if we had a different subnet mask. Number of possible hosts in each subnet. Well, how many host bits are left? So 2 to the 4 host bits are left. That equals 16 IPs, but we have to subtract 2, one for the network ID and the other for the broadcast address. So we have just created 16 subnets, and each subnet will be able to hold, or be able to use or allocate, assign 14 usable host IPs. So let's go ahead and work this out. So 197, let's make it a better 9 there, 197 dot, where are we at? 47.201.0. Excuse me. So remember, our block size is 16. So 201.0, 201.16, 201.32, 201.48. And I'll come over here and do the rest over here. So 201.64, 201.80, 201.96, 201.1, not 128, hold on, 16, 112. 112, is that right? Yeah, 112. There we go. And then 128. And then we have .144, .160, .176, .192, we're going to go up here by 16, 208, and then .224, .240, and that'll do it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are the 16 subnets. If we take a look at the broadcast IP, remember with the Class C, when we're subnetting Class Cs, it's literally going to be the address right before that address. So we would have 197.47.201.15, and then it would be .31, and then .47, and then .63. And this is the fourth and final octet in the address. So valid host IPs, it's going to be from .1 to .14, and there are my 14 usables. From .17 to .30, there are my 14 addresses. From .33 to .46, right? Because it's one less than the broadcast and one more than the network ID. So .49 and .62. And so we'll leave this here, and then you could fill the rest in based off the values that we have. And again, very nice and easy Class C example to work ourselves into what typically causes a little more anxiety, and those are the Class B subnets. And can we get this all on one? Yeah, we're not going to get that all on one sheet. So let's start. We'll go right there. We should get, it's pretty close. All right, so now we're talking about a Class B address, right? Because the first octet, the value is 159, and that falls between 128 and 191, right? So what class is the address? It's a Class B. So we know we're going to be interested in that third octet. Very important. That's the one we're going to be manipulating. The default mask in binary for Class B, 1, 2, 3, 4, is a /16. And then we've got our 16 host bits. 1, 2, 3, 4. And then 1, 2, 3, 4, 1, 2, 3, 4. And then in decimal, it's simply going to be 255.255.0.0. We'll line these guys up here. Now, we need 7 subnets. So we should know right off the top that 8 is going to be what we want, and 2 to the what is 8? Exactly, 2 to the 3 is equal to 8. So we're going to borrow 3 of those host bits. We need to borrow you guys, 1, 2, and 3, and turn you into network bits so that we can create 8 subnets. So now the question becomes, what is the new subnet mask in binary? Well, it would be 4, 1, 2, 3, 4. Is that right? 1, 2, 3, 4, 1, 2, 3, 4, dot 1.1.2.3.4 dot 1.2.3.2.3.4.5 dot 1.2.3.4.5.6.7.8. So there are our borrowed bits, and let's go ahead and jump on highlighting excuse me, the rightmost borrowed bit, and we know the value for that is going to be 32, right? Because 128.64, 32. So our block size is 32. In fact, let me switch back to red here. So the new subnet mask CIDR, the first 19 bits are network bits, and our decimal, dotted decimal subnet mask is 255.255 dot, we've got 128 plus 64 plus 32 is going to give us 224.0. So number of possible subnets, we've got 8. Number of possible hosts in each subnet, we've seen this number before. We've got 8, 9, 10, 11, 12, 13. So 2 to the 13 equals, and I am going to confirm this. Sorry about that. I want to say 8192, but let me check this really quick here. It's either 16,384 or 8192. So 2 to the and all right, there we go. I've got my sheet out here. So 225, 224, yeah, 8190. That is correct. All right, because we saw that just before on the previous exercise. So number of possible subnets is 8. I was trying to fill this in here. So this is going to be 8192, and then we're going to take away 2, and it's going to give us 8190. So 8,190 usable host IPs, and we have 8 subnets. So let's go ahead and fill our subnets in. So the subnet ID here is going to be 159.23.0.0, and then 159.23.32.0. Again, manipulating that third octet, .64, .96, .132, 128, .160, .192, and then it says etc. so on. So we'll stop right there. So my broadcast address, and let's see if I can keep this straight here as I transition from row to row. Unlike Worksheet 11, it kind of turned into a mess toward the end there. So for the first subnet, the broadcast IP is going to be the IP right before we would roll over to 32.0. So 159.23.0, I'm sorry, .31.255. So 159.23.31.255. So the broadcast IP for 159.23.32.0 for this subnet ID would be 159.23.63.255. Again, it's the address right before 64.0. Because remember, we can't go up to 256. We then roll up one number. So for 64.0, it would be 159.23.95.255. And then it would be .127.255. And then it would be .159.225. .191.255. And of course, our usable IPs are going to fall into the range here in the middle. So we would have .0, .1, all the way to .31.254. And this is in that range. That's 8,190 usable host IPs. So same thing here, .32.1 all the way to .63.254. .64.1 all the way to .95.254. .96.1, .128.1, .160.1, and .192.1. And of course, the broadcast address, or I'm sorry, the last usable IP is one less than the broadcast address, 127.255. .159.254.191.254, and so on. Okay, so this is actually going to go ahead and wrap up worksheet number 12, where we had an exercise where we had to come up with a Class C set of addressing scheme, as well as a Class B addressing scheme. All right, guys, well, that's it for worksheet 12. Enjoy the rest of your weekend, and I will see you all on Tuesday evening.